the question has come up, is there any evidence of a catastrophe that could be associated with the mid-Atlantic ridge? We're putting out the hypothesis that Atlantis, we're testing the idea that Atlantis is pretty much where Plato said it was, right?
Right.
Now, I know there's been a lot of discussion about all of these other places, and many of them are very interesting in their own right, but they have to deviate from Plato's account. And if somebody has some really solid evidence, I'd like to see it, that it's somewhere else, without changing the details of Plato's narrative or reinterpreting the details of Plato's narrative. Now, over the years, I've gone through, I think, 5 different translations of Plato and have referred back to the original Greek as much as possible to try to get the sense of what he's really talking about. In the various translations, there are some discrepancies and so on, but the overall major details are pretty consistent, right? So, and he uses the word Nessos, which translates as island, and I think we need to stick with that. And the Richat structure that a lot of folks are looking at, we can address that. We can address that in the next topic, if you will. There are multiple reasons why that doesn't really make sense as another candidate for Atlantis. I think that it can be most readily explained as a natural feature, and it's not really the same size as what Plato describes. There's a huge discrepancy in the size of the thing, and we can get into that in details. I can have some specifics in the next podcast to address the Richat structure. But for right now, I think what we're going to do is we're going to address some of the evidence for catastrophic events that could be associated with the Atlantic Ocean basin, and more specifically along the mid-Atlantic ridge. So back in 1992, the journal Geology had an article. It was addressing discoveries made in the Rift Valley of the mid-Atlantic ridge, because there's essentially a valley there between the two plates. And the title of the article was Massive Submarine Rock Slide in the Rift Valley Wall of the Mid-Atlantic Ridge. Now, this is what they say. Within the past 450,000 years, a section of ocean crust, approximately 4 by 5 meters, that's about 2.5 by 3 miles, was removed from the eastern wall of the Mid-Atlantic Rift Valley in a massive rock slide that disintegrated to form a debris avalanche. The debris avalanche flowed more than 11 kilometers, which is about roughly 6.5 miles, into the Rift Valley and deposited a debris wedge with a volume of approximately 19 times 10 to the 9th cubic meters, which is like 19 billion cubic meters, or about 1.5 cubic miles of material. And that is a really big rock slide.
Yeah, that's a lot of stuff.
Yeah. He goes on to say that there are many factors known to contribute to the failure of slopes. He says most of these, though, can be discounted for the submarine hard rock environment of the mid-Atlantic ridge, and only 4 are likely to be significant, saying that it was a pre-existing structure, which he pretty much dismisses that possibility. Slope over steepening, just, what happens if a slope gets too steep, then gravity can go to work on it, cause rock failure. But the final of the 4 that he mentioned is really, to me, the most germane here, and that is seismic shock. Seismic shock, he says, probably was important, and it may have provided the ultimate trigger for failure, right? So of the various possibilities that he's invoking, he's definitely leaning towards the seismic shock. Now, of course, the time frame that he gives within the past 450,000 years is not enough to attribute it to any kind of a catastrophe that would have been associated with the subsidence of an island complex along the mid-Atlantic ridge. And in regards to that, he says, we cannot pinpoint the time at which the mid-Atlantic ridge crust failed, but it can be constrained by crustal ages. The rock slide must be younger than 450,000 years. But he also says, and this is where it's significant, a very recent age cannot be ruled out by the existing data. So we have this evidence of this massive rock slide, huge massive rock, pummeled down into the Rift Valley of the Mid-Atlantic Ridge, cubic mile and a half of material. The author of this study thinks it's most likely due to seismic shock, seismic shaking, and he also points out that it could be very recent. In other words, when he's talking about very recent, he's not talking about the last 1,000 years, but he is possibly talking about, terminal ice age, in that window that is, proving to be so important and interesting, that window from, roughly 11,000 to 14,000 years ago. That in itself is kind of interesting. And then we have another study from the Canary Islands. We can pull up some maps here in a minute so people can kind of get the geography of this thing. This appeared in the Journal of Geophysical Research in 1995. The title of the article is "A Giant Landslide on the North Flank of Tenerife in the Canary Islands." This study of sonar data from the north flank of Tenerife allow the following conclusions to be drawn. The north flank of Tenerife is associated with a giant landslide which covers an area of at least 5,500 square kilometers of the seafloor, more than twice the surface of the island. The landslide has an estimated length of 100 kilometers, a width of up to 80 kilometers, and a volume of at least 1,000 cubic kilometers. The landslide can be traced onshore to the Orotava and Icod valleys, which are underlain by a chaotic breccia that was formed by one or more landslides. Now, breccia, we'll define that term. Breccia just basically means broken rock. So you will have breccia that can be associated with rock falls, landslides, mass wasting events, volcanic explosions, and more importantly, even meteorite impacts, which can break up tremendous amounts of rock, creating breccia. So you will have in the case of a meteorite impact, you can have fallback breccia, right? Because the impact hits with a tremendous amount of kinetic energy, the material is thrown up, the rock is blasted up into the atmosphere, and it falls back. So if you're reading a lot of literature about asteroid or meteorite impacts, then you're going to encounter the term breccia, and more specifically fallback breccia. Okay, so he says a young age for the landslide is supported by 3.5 kilohertz echo sounder data, which show that the toe of the landslide is draped by a sediment layer less than 10 meters in thickness, probably equivalent to 20,000 years of sediment deposition. So now what they're saying is this giant landslide is probably within the last 20,000 years. And then we have, again, another one from 1999, another study, repeated debris avalanches on Tenerife and genesis of Las Cañadas caldera wall on the Canary Islands. The Cañadas volcanic edifice of Tenerife, Canary Islands, is currently indented by the Las Cañadas caldera, a semi-elliptical depression having a northeast trending axis, 16 kilometers long, and a southeastern wall as high as 500 meters, which is, 1,700 feet up in there. So that's a huge wall, right? And it's semi-elliptical. The origin of the Cañadas caldera has long been debated. In this paper, we focus on the avalanches, differentiating several successive events that we interpret as repeated lateral collapses of the Cañadas edifice, and that can explain the scalloped horseshoe trace of the caldera wall. The recent discovery of more than 1,000 cubic kilometers of volcanic debris spread widely across the seafloor north of Tenerife is a strong argument in favor of that hypothesis. There is geologic evidence on land of 6 north-directed flank failure events. This repetition of flank collapse is consistent with what is now known about many other oceanic islands. Canarian examples have been described for El Hierro and La Palma Islands. So basically what we're getting at here is we're seeing that these islands have been subjected to these massive slope failures that have cause huge amounts of material to fall into the ocean and spread down onto the floor of the abyssal plain. Now, if we go back, let's see if I can pull up a map here so we can see, get the big picture here. Yes, okay, here we go. I'm going to share screen. All right. Are we seeing this screen?
We are.
Yeah.
Great. All right, so we can see in these islands, like let's take a look at El Hierro down here. Can you see this feature right here where I'm pointing out with the, the cursor? Okay, that kind of horseshoe-shaped scallop was a huge landslide that fell into the ocean. Right here, you see the same thing, right? Over here, look at this.
Oh, yeah.
See that? Now, here's a map showing the various islands, and each of these gray areas represent these huge slope failures and flows into the ocean. So if you look up here at La Palma, you've got 3 great slope failures coming off. You see the lighter gray and the darker gray to differentiate. And El Hierro, you've got what's called the El Golfo failure. You got Las Playas over here and El Julian over here, right? So you've got these massive events where you've got huge amounts of material that have been catastrophically ejected from the island slopes, and you've got multiples. So what this is probably telling us is that there have been a series of events through time, right, where there has been this massive destabilization that has led to the failure of the slope failure of these island flanks. Now the question is, when would the last one have been? And is there a sequence? Is there a periodicity to these? The dating at this point is still premature, so we can't draw any hard and fast conclusions at this point. But the evidence here, you see, for these, you could have several things going on here, and it's undoubtedly a confluence of things. For one thing, if you have a major seismic event, right, a seismic shaking along the mid-Atlantic ridge, this is going to generate, it's going to do 2 things. It's going to cause weakening of the island flanks, and it's also going to generate large-scale tsunamis, which between the 2 agencies of seismic shaking and tsunamis would pretty much explain most of these flank failures on these islands. But the point is that this is not normal erosion. This is evidence of major events that have affected this region of the Atlantic Ocean.
What are the question marks on there? Do you know what those are? There's 1, 2, 3.
Yeah, okay. Question marks might be the origin, the ultimate origin of the material.
Okay.
Yeah, because when you look at the contour lines, you're looking at if you go down deep enough in the water, you're looking at one large island there.
Right. It does look
large
like
landmass.
Now this is not the Azores. This is the Canaries.
Right.
Which is east of the Azores, offshore of Western Africa.
Right.
However, a major seismic event along the mid-Atlantic ridge is going to leave its imprint all around the Atlantic basin. And if you had a major seismic shaking along the mid-Atlantic ridge and you had tsunamis generating outward from that area, the Canary Islands are going to be right in the direct path of that.
Right. Well, and if the water, and given that the water levels sea levels were much lower during the Ice Age, those contour lines are going to be, much of the contour is going to be above water.
Water, yeah.
Yes, that's right. Going back from the paper here, there is geologic evidence on land of 6 north-directed flank failure events. This repetition of flank collapse is consistent with what is now known about many other oceanic islands. Canarian examples have been described for El Hierro and La Palma Islands. The total volume lost in the avalanches can account roughly for the volume of volcanic debris observed on the seafloor north of Tenerife. 3 distinct collapses produced different segments of Las Cañadas caldera wall and a fourth produced the Orotava Valley. Together, they compose a multi-episodic lateral collapse structure roughly 25 kilometers wide, which is going to be about 12, 13 miles right in there. Let's go back and look at some more maps. So this is the Canaries right here. And here is satellite images, which we just looked at. And here is the map showing the avalanches down on the ocean floor that are surrounding the flanks of these islands. So yeah, this study of sonar data from the north flank of Tenerife allow the following conclusions to be drawn. The north flank of Tenerife is associated with a giant landslide which covers an area of at least 5,500 square kilometers on the seafloor, more than twice the surface area of the island. Here's a map of Tenerife. So this whole area up here is the main area where material was removed and swept out into the ocean floor. Now, if you think about the action of tsunamis, what do? They come, they rush ashore, right?
Yeah.
And then they reverse direction and they flow back out to the sea. And what do is they're flowing back out.
Drag a bunch of
they drag material with them, don't they? Yeah. Now, if you have a combination of seismic shaping and tsunamis, yes, I think that we're looking at an agency that would be very effective of causing massive flank failures on these islands. And here, if we look at Tenerife, we can really see the islands are volcanic, but this whole area in here. And actually, you can actually, if you look closely, you'll see that you've got this textured material where it's these lineations moving towards the sea, right? And if you go offshore, this material here continues, this huge mass of material continues off, onto the ocean floor. Yeah, here you can see now, here's Tenerife here, and then these outlines show these huge mass wasting or flank failure events. And it looks like there's at least 3 of them. What's important here is we need more studies pinpointing the age of these events. And were they all compressed within a very short period of time, or are we looking at something that maybe the earliest ones are associated with an earlier ice age and an earlier regression of sea level and rising of sea level, perhaps associated destabilization in the Atlantic basin? At this point, we don't know. And I'm sure there are studies that have come out in recent times that I've missed because I'm trying to follow too many things at one time, really. But this is extremely interesting stuff. And it'd be interesting to see if there's been, in the last few years, any more precise dating of these avalanche events.
Yeah. So they mentioned multiple times that they're north facing.
Yeah, pretty much. They're facing in the direction of a wave coming from the direction of the Azores, which is kind of northwest of the Canaries. And so, yeah, here's the north flank of Tenerife as viewed from the northwest. And here you can see southern wall of the Cañadas caldera here, and these mass wastings that spread out onto the ocean floor. So yeah, map of area of giant landslide off the north flank of Tenerife right here. The Cañadas volcanic edifice of Tenerife, Canary Islands is currently indented by the Las Cañadas caldera, a semi-elliptical depression having a northwest trending axis 16 kilometers long. Okay, we've covered that. All right, now here, another map, and you can see you've got El Hierro down here, and look at here, the debris flow, how massive it is. And it's basically, if you imagined a tsunami whose epicenter was in the region of the Azores, like if you had a massive seismic collapse of the Azores and a seismic wave moving outwards from that, striking the Canaries, and then the resurge wave moving back, it would pretty much be defined by this direction right here. Yeah. This massive debris flow that stretches out tens of miles out into the ocean floor. Yeah, now here you can see El Hierro, the collapse feature right here. It's very plain to see.
Yes.
This scalloped indentation on the northwest flank of the island.
Well, those islands must have been quite a bit bigger before that happened.
Oh yeah, absolutely. Yes,
Yeah.
yes. And this is the one of the few photographs I've been able to find until we actually get out into the field and get there and get Bradley. Obviously, we're going to need some drone footage here, but this is what the El Golfo embayment, this scalloped feature on El Hierro, looks like from the ground, and you can see this whole rounded thing. So all of this material in here has been removed from the flank of the island and swept out to sea.
Wow.
So
and there's good evidence. I take it from some of the excerpts you're reading from the paper. There's good evidence that those events took place all at once. Like it wasn't. This is not a gradualist thing.
yes, well, yes. For example, what we're seeing here, if we go back to this image right here, which was the map we were looking at. The question you asked, okay, each of these represents a distinct event.
Right.
Right.
Okay.
So, right, when we look at Tenerife, we see that there's at least 3 distinct events there.
Yes.
And then this Teno would possibly be a 4th. This Anaga would possibly even be a 5th.
Right.
So yeah, all of these are not one big event, but 1, 2, 3, 5 discrete events. The question is how much time elapsed between each event and when was the most recent one? That is the critical question that we're interested in here. The limited dating that does exist is quite suggestive. Now, this is from a study that appeared in the journal Geology in 1996, discussing the catastrophic collapse of the volcanic island El Hierro and the history of landslides in the Canary Islands. This is what he says in the abstract. Landslides play an important role in the evolution of many volcanic islands, producing huge fields of blocky volcanic debris on their submarine slopes. Side-scan sonar images presented in this paper provide evidence for a large debris avalanche, El Golfo, on the northern flank of Hierro Island in the Canary Islands. Angular blocks, get this, as much as 1.2 kilometers across and 200 meters high. So that would be...
Those are big blocks.
Those are like 4,000 feet across, right? And say 700 and some feet high. That's a big block. Yeah, that's a very big block.
It's a huge block.
So angular blocks as much as 1.2 kilometers across and 200 meters high cover the debris avalanche surface. El Golfo avalanche is related to both the Canary debris flow and volcaniclastic turbidite found in the Madeira abyssal plain 600 kilometers west of the Canaries. Let's back up. Volcaniclastic. Clastic just means chunks of rock, basically, right? Pieces of rock. Volcaniclastic means that it's related to genesis through volcanism, probably a volcanic eruption. So you've got, again, I'll read that. El Golfo avalanche is related to both the Canary debris flow and a volcaniclastic turbidite. Essentially, just think of turbidity, to huge, chaotic water flows across the bottom of the sea, right? Picking up and moving lots of sediment, right? So you have a volcaniclastic turbidite found in the Madeira abyssal plain, 600 kilometers west of the Canaries. Dating, now here's where it gets interesting. Dating of the turbidite and the failure scarp onshore indicates that the failure probably occurred between 13,000 and 17,000 years ago, which puts it damn close.
That is.
And 13,000, of course, puts it right there at the Younger Dryas boundary. If this dating turns out to be typical of some of these landslides, we're getting... That would go a long way towards showing that there were seriously catastrophic events in the Atlantic Ocean basin at the end of the last ice age, which puts these catastrophic events within a millennium or two. And of course, the error bar of this dating might be 1,000 years or more.
Right.
So we can't rule out that, this dating might be consistent with the subsidence of Atlantis.
Yeah, and then there was the other one you read where there was one of the landslides had a sediment load on top of the tongue of it, or
Yeah.
the toe of it. They said that was roughly 20,000 years old, which is still ballpark. So,
Which is still ballpark. Yeah, exactly.
it's a guess on sediment dropping from the ocean. Yeah.
And then here we have a from the side scan sonar, surface of the debris avalanche from El Hierro. The large blocks in this picture, like you see where my cursor is right here, that would be a large block. Some of these large blocks, I know you can't tell because of the scale invariant nature of these geological phenomena. These large blocks are up to about 3,000 feet across. So that's basically a kilometer. So this was clearly a very catastrophic event.
Yes.
And
that
the evidence of this catastrophe
like
is
a shallow. It looks like shallow water on a beach right there.
Yeah.
You know, like those are little pebbles in
Yeah,
the shallows.
they're not. They're huge, huge blocks.
It's crazy.
Here's El Hierro, and you can see the terminology here. You can kind of see where it says landslide debris. That is the side scan sonar image that we were just looking at. And so these blocks down here are these, 3,000 foot across blocks, 700 feet thick. You've got what they're calling the landslide chute, and then you've got the head wall scar. So we've got some terminology there. Head wall scar, I like that. The landslide chute, and then you have the debris apron that's spread out onto the ocean floor.
Is this a volcanic mount?
Yes, the Canaries are volcanic.
Right. Where's the caldera in this case? What we're seeing there is one side of the volcano's
Pretty much,
cone?
yeah. Pretty much, yeah.
Yeah, so it's eaten into the volcano itself. Yeah.
Yes.
That's interesting.
So
And
one side of the volcanic cone has collapsed.
completely
wall.
collapsed, yes.
That's amazing.
Here's the island of El Hierro, and here's the El Golfo, right, debris fan. Here is the head wall scar. Here is the landslide chute. But then we've got off to this side, we've got another flank failure, El Julian. Over here, we've got Las Playas, and it looks like two episodes. You've got one that reaches out to here, and then another one that came down on top of it. Okay, here we go. El Julian embayment. They're dating that at more than 160,000 years ago. The Las Playas at somewhere around 145 to 176,000. The El Golfo is the one that they're dating between 15 and 20. But that's interesting because it's from the same paper that just said it was from between 13 and 17, which actually makes more sense than 15 to 20, because 13 to 17 would be right there in the deglaciation and consistent with meltwater pulse 1A and 1B, which could certainly be enough to trigger a destabilization along the mid-Atlantic ridge and cause seismic activity. So it seems like, yes, you've got a succession of these massive catastrophic flank failure events stretching back several 100,000 years, with possibly the most recent ones occurring again at the end, near the end of the last ice age. La Palma, this is the one you were talking about, Brad, where there's the unstable flank.
Right.
Yeah. And here you've got it showing, let's see, Cumbre Nueva here, which is one, Santa Cruz over here, which is another one, Playa de la Veta or Vela, this one. So you've got multiple events. You'll have a catastrophic flank failure, then time passes, you'll have another one, and that debris avalanche then will cover the earlier one. Got another paper here, correlation frequency of emplacement and source directions of mega turbidites on the Madeira abyssal plain. This paper describes the sediments of the whole Madeira abyssal plain. The plain is made up of a series of large turbidites separated by thin pelagic layers. Would you look that up for us, Kyle? And give us the very PELAGIC, pelagic layers, which can be used to provide a high-resolution stratigraphy back to about 750,000 years. Many of the turbidites were deposited close to oxygen isotope stage boundaries, suggesting a strong relationship to sea level change and climate change, although the exact initiation mechanism for the flows is not known.
Of or relating to or living in open oceans or seas rather than waters adjacent to land or inland waters.
Yeah, living in the open ocean. And we learned that the term benthic last week, which was referring to creatures that dwelt on the bottom of the ocean. So now here, let's come back to this paper that appeared in Marine Geology in 1992. Embley, in 1982, mapped numerous sediment flows on the northwest African margin, including the Saharan slide, which originated on the continental margin south of the Canaries in a water depth of 2,000 meters. Embley's original Saharan slide is now known to be a combination of two slides, the second being termed the Canaries slide, since it originated about 4,000 meters water depth off Hierro. This Canary slide formed debris flows which nearly reached the edge of the abyssal plain. Both the Canary and Saharan slides have similar ages and are probably related to the same erosive event which occurred in this region, get this, at the end of the last ice age.
Mm.